Hello everyone. This is Urja Pawar. I am a first year PhD student in Cork Institute of Technology, Ireland, and I am supervised by Dr. Donna Oshia, Dr. Susan Ria, and Dr. Ruairi. The topic on which I submitted my research abstract was Explainable AI in Healthcare, and we will see what Explainable AI is and what is its importance in healthcare. So I'll start by discussing in general what is the impact of artificial intelligence in smart healthcare. Then I will discuss about the challenge of black box operation of AI models. Then I'll discuss how explainable AI, also known as XAI, can help in addressing that challenge and how it impacts healthcare. Then I'll discuss some of the challenges in explainable AI and followed by proposed approach that I think will benefit clinical workflows. And then I will conclude. So first of all, smart healthcare. Smart healthcare refers to the use of technology to enable an efficient, convenient, and personalized healthcare system. Artificial intelligence, AI, is one of those technology that is used in smart healthcare to predict occurrence of certain health conditions by capturing patient health records. It is already showing early signs of adoption in medical imaging, early detection of life-threatening conditions, diagnosing diseases using patients' health record, or optimizing treatment plans. And because of these early signs of adoption, we are already seeing that there is an estimated savings of around $150 billion by 2026, as per Accenture. Because of this, there has been already heavy investments for AI in healthcare. And as per Forbes report, the total public and private sector investment in AI for healthcare is expected to reach $6.6 billion by 2021. Now, this is the impact of AI in smart healthcare. But we do see a lot of research happening around this space, but why not it's actually getting adopted in hospitals or health institutions? One of the issue is the black box operation. Now, by black box operation, I mean when I provide an input to a particular system and I receive an output and I don't understand what is happening beneath that system, that's a black box for me. AI-based systems work in a fashion that we provide some input data and we get some predictions or classifications, and we usually don't know how the AI system reached that prediction and how it actually operated on it, so that we can understand that, okay, because of these factors we are getting this classification, or this AI model works considering these factors. So the whys and the hows are not clear to us. That's why AI-based systems are difficult to interpret, and that is because of the complicated underlying operations. Because of this, clinicians are hesitant to use AI-based systems as they don't fully understand them. That's where explainable AI or XAI comes into play. Now, what explainable AI is, it is a domain in which we have models that can be used to make AI models interpretable and explainable. There are two terms now, interpretability and explainability. And we will see what these terms mean in this example. So for example, I have an AI model which works in a way that I supply a CT scan of lungs, and the AI model says that this particular scan can be classified under lung cancer, and this is not normal. So if I understand how the AI model works in an overall way, that is interpretability, which is extent to which a cause and an effect can be observed within a system. Now, after the classification is done, I have to tell clinicians that because of these factors, because of these segments of the scan, it was saying that this particular scan belongs to a patient having lung cancer. So that's explainability. That is extent to which the internal mechanics of systems can be explained in human terms. Now there has been a many research going on in this field, and there are certain challenges in XAI. So the explanation generated by XAI methods should be useful for end users, that can be clinicians in the healthcare domain, and the user should be having expertise in their domain. So for example, clinicians have expertise in medical domain. So right now the explanations that are being generated are just will give you the gist of what is happening, and not actually being useful to the normal users, which are experts in that particular domain. So we need to have some frameworks that can be generate some explanations that can be directly useful for the people who are expertise in that domain. And for that, there needs to be a development of appropriate user interfaces to effectively display explanations. And challenges related to explanation, for generating explanation, automatically tells us that there will be an increased computational cost apart from the original AI model. And the existing XAI methods work in an assumption based manner. So they assume that the certain set of AI models follow a certain set of rules, which is not applicable to all set of AI models. And that's why the explanations generated from these XAI methods cannot be trusted. So this area related to increased computational cost and assumption-based operation remain an open area for research. Benefits of having XAI in healthcare, that it's needless to say that if explanations are provided along with the predictions, there will be a better understanding of AI models that will help in gaining confidence from clinicians, as XAI will help in demystifying the black box operation. If we have interpretable AI models, that will enable a better transparent system that will again, enable adding a layer of trust while using these systems. Explanations of classifications can also help in tracing erroneous results and increase accountability. Sometimes it might happen that a particular prediction is wrong, and then we want to trace the cause of that prediction, because in clinical domain we cannot afford to have wrong predictions or wrong classifications. So in that case, we can the explanations can be tallied from the clinicians, and then we can say that okay, this factor was not actually important while diagnosing this disease, and then we can improve our AI model to better concentrate on the features that matter. So a simple proposed approach that I mentioned in the abstract was like this. First of all, our application that has the AI model will capture the health information that is used by the trained AI model to predict the probability of certain diseases. Now, this prediction, along with the original health data, can be used by existing XAI methods to generate explanations. These explanations can then be analyzed with the help of clinical knowledge and will enable validation of predictions made by the AI model. Now, for if in this particular example, we assume that there is a certain disease that our AI model was trained on, and it took factors such as age, gender, BMI, blood sugar level, etc., etc., and it classified a particular patient health record as some, falling under some disease. So in that case, we can tally our explanations with the clinical knowledge and see how much they match. If the clinician believe that the prediction is wrong and it needs improvement, we can tally our explanation and seek his or her knowledge. So for example, clinician might say that age is not quite important while diagnosing this disease. So we will go back to our AI model engineering, and we will improve our feature engineering process in a way that age is not considered while training this AI model. However, if the predictions are correct and the explanations do tally with that of clinical knowledge, then we can generate appropriate insights and recommendations to the patients based on the explanation. So for example, if explanation says that because your blood sugar level or BMI index was high, we predict that you have a higher chance of getting diabetes. So then clinician can verify this particular assumption that was born out of explanation, and we can recommend user to better control the body mass index or blood sugar levels, or to monitor the calorie intake. So in conclusion, I'll say XAI can be used in the analysis and diagnosis of health data by AI-based systems in a more understandable format. Research in XAI can address the development of frameworks and models that help in interpreting and understanding the decisions being made by the AI systems. The recent European General Data Protection Regulation, GDPR, calls for making results generated by autonomous systems used in businesses traceable, and XAI techniques can be utilized to make results from AI-based autonomous systems explainable and traceable. Transparency, result tracing, and model improvement are some of the other benefits that can be offered by XAI. Thank you, and I'll be happy to answer any questions you have.
Thank you so much. That was really interesting. So guys, attendees, if you have any questions, please do pop them up into our Q&A. So I understand this is, so your first year PhD student, this is what your PhD is going to be focused on.
Yeah.
I assume. So it's quite early days for you on the PhD journey. So has there been any research out there on, and you kind of mentioned that clinicians might have issues and maybe, let's say, resistance or difficulty around using any kind of AI. And we've seen there's been a lot of research over the years about clinicians' resistance to using any kind of technology in the health setting, you know, anything even like electronic health records or stuff like that. Has there been any research on health professionals and their perceptions of these kind of technologies that you've come across?
Yes, there has been. But the explanation, the tallying of, okay, so there are two parts of it. The research on applying XAI methodology in the medical domain has been done.
Okay.
But we have very limited research in terms of whether those explanations are qualitatively assessed with clinicians, whether
Okay.
they're actually helpful to them. There has been, but it's very limited. So that needs to be done, whether the quality of explanations matches with the expectations of the clinicians.
Okay, yeah, but there's probably a lot to explore within that. So
Yes.
we've a couple of questions coming in here from Cyril. So well, hold on 1 second. So he says his first question is, what tools do you use to explain AI?
So in this particular abstract, I was thinking of using frameworks like LIME, which is local interpretable model agnostic method. And then basically what that method does, it is able to explain the prediction. So if a particular particular patient health record was found to be diabetic, so that particular framework will just tell us that, okay, these features were involved in having the I cannot switch on my camera.
Yeah, that's okay. That's okay, don't worry.
This particular predictions can this particular factors were responsible for it. So it does not explain the overall functioning of the model, but it can help in explaining just single prediction.
Okay.
So that can be used. Then there is similar methods like Sharply, anchors. Both each one of them has their own pros and cons. For example, anchors are better than LIME in coverage of predictions. So in LIME, you have to train a single model for explaining a bunch of predictions, but anchors give a much wider coverage of predictions by just one single model. So there are, then again, pros and cons of every method, and we have to see. And my PhD actually targets developing a whole new XAI model that can, address some of the key issues there.
Okay, great. We have a couple of more questions coming in. So Cyril says, and I guess it's kind of a follow-up, can the explanations aid a novice professional in explaining a subject, even though they might not be a subject matter expert in that field? So is that a potential use, I guess, of explainable AI, is aiding those novice professionals in explaining?
I didn't get the question.
Can you see it here? Should we come up here?
I'm not able to see. It's just Zoom webinar chat, right? I'm not able to see
So it
that.
should be in the Q&A. Can you see the Q&A there?
Yeah. Okay. So can explanation aid a novice profession explain a subject, even though he or she may not be a subject matter expert in that field? I guess yes, because it just matters in which domain I'm applying my explainable AI model to. So if it's something that it contains features, for example, I'm able to, explain a model that whether you should go ride a bicycle today based on weather, or based on time of the day, based on day of the week. So you will be able to understand that, okay, because today is weekend and this is 5 to 6 p.m. So that's why I'm predicting that it's a good time to ride a bicycle, because there are, I don't know, less chances of uh, rain or something. So it depends again on profession. It depends what features my AI model takes to predict something.
Okay.
So if clinical domain, then the features will be obviously related to medical things, and there I actually require subject expertise to judge the explanations.
Right. Okay. Yeah. So the professional should basically know as much as
Because
the.
there was a case, in some research paper I read that uh, there was a case in which pneumonia was predicted using some features,
Yeah.
and uh, it was based on neural networks. And what it used to do was, if a particular patient already has asthma, then it was predicting them to be outpatient, that is, they need not required to be admitted to the hospital. So
Okay.
that is weird, because the patient who are having asthma are the most priority patients to be submitted directly to the ICU if they get pneumonia. So there you need interpretability and explainability, that what factors are you taking in. So you get.
Right. Yeah. So how is this machine giving me this answer essentially? And there's no blind trust, especially in the health professional, in the health setting, right? They need to have their own interpretation. I guess. So we have another question here from Gwen. So do you plan to explore interpretability with patient data in situations where models have been privately trained, using secure multi-party computation or homographic encryption, etc.?
Yeah, this question is actually been asked a lot to me in my PhD presentations as well. So I have not yet touched the private, because that is toward. Grace Fox would like to answer this question live.
Oh yeah, no, that's just so other people can see it. Don't worry.
Okay,
Yeah.
okay. So it's that what I was going to say. Yeah, that is towards responsible AI. Explainable AI is a like subdomain of responsible AI. Responsible AI works towards everything that is makes AI ethical and good to use in business sectors. So the issue of confidentiality, privacy, these things are overall dealt in responsible AI. I will of course explore that area, but I'm not sure whether I'll be able to achieve something. And if I'm interested in building those type of models, my primary aim still remains that it should be beneficial to clinicians.
Okay. Yeah. you're very wise already looking at the parameters of your PhD. It can be very, it can be very easy to, you know, get a project creep and just pursue whatever's interesting. So I think that's probably a wise decision. Cyril asks, do you think explainable like AI is challenging and potentially more impactful in healthcare compared to other contexts?
Explainable, so compared to other fields, I don't think that's the case, because if I would like to have similar impact of explainable AI in, you know, things like, for example, in criminal, so in criminal justice type of things, where we use face detection methodology to, you know, detect whether a particular person can be is suspected to be a criminal or not. There also we need to have explainability and interpretive, that why our AI model is predicting that this can be a suspected person. So wherever actions and decisions matter a lot from AI based systems, explainable AI will have a huge impact.
Yeah, I think that's a good.
Okay, so the last one is, what custom metric do you intend to use to score qualitative feedback in order to determining your model's performance? So there is this consistency parameter that I've thought, and, you know, many papers have also discussed. It is basically based on identity, separability, similarity. So identity means if I'm talking about two similar instances, two same instances, for example, two patients having same type of biological parameters are predicted to have same disease, the explanations for both of them should be same. Similarity, two patients having similar type of patient data are predicted to have diabetes, their explanation should be similar. So I will try to, you know, give the quantitative value to these things, but I have figured out that, yeah, identity, separability, similarity can be the initial points for me to measure the quality of my explanations.
Great. Okay. Listen, thanks for that and for your response to all the questions. That was really interesting. And I wish you the best of luck on your PhD journey.